Плюс. Мгм. Здравствуйте, коллеги. А,
Hello, colleagues. Today at 6:30 we'll have a gig and some beverages and refreshments. Don't forget about our small party. I did my duty. Okay, hello once again. My name is Max, and I'm a developer working in the company called Viva Studio. I work with C++, Java, and C Sharp. Today we'll talk about static static analysis, not about something narrow, a methodology, but about something general. We'll look at classical ways of using it, and we'll go deeper and then, examine alternative uses. What can be understood as static analysis is a number of methods that extract certain information from various data using certain rules. During the previous SQA Days conference, I explained to my colleagues that every year static analysis is becoming better for debugging, but it's actually much bigger than this. Methodology is much wider than this. Various data can be subject to analysis. It all depends on various source data and requirements. In the slide you can see some data that can be used to extract information. Today we'll look at it in more detail. So the best way of looking at it, the analysis, is the analysis of the code database. If you Google it on the internet, this statistic analysis, we will start with hand in hand with the regular approach. Is the most widespread approach, is determining fragments of code with defects. Besides, the statistical analysis helps very well in formatting code and calculating metrics, and code documentation, and so on. In order to extract certain information from the source code, you need to change the code. So abstract syntax tree is a way of presenting information. In this case, it abstractly presents the syntax structure. It's done with the help of a syntax parser. And the nodes in this internal nodes are bots or nodes where the management can come from outside. Apart from this, the abstract semantic graph. This is not a major topic of our conference, but let's look in detail at the information we can extract from the source code. The most popular one is the search of the code fragments containing some defect. Could be a bug or potential bug, some vulnerability or the narrow spot. In order to extract certain information, we apply various technologies and various techniques, like search of the mistakes or errors using the AST. Using this technique and technology, we find the technological samples that drafted during the code procedure. Also, the use of the semantic model helps to find various errors. The analyzer will know additional information. For example, it's a variable, it will know its type. If type consists of classes. It will know the heritage and so on. The next one is the analysis of the data flow. It can be built used on management flow management graph. It allows to model the of the work at a certain point of time. Or it could be also always true, always false values. Those of you who are interested in this, you can watch the video about my with my presentation using the uh, QR code. Also, static analysis helps to format the code. It is well known that when a program is being developed, some people write the code, others read the code, and some do both. The logic of each person is very individual. So the differences in code stylistics will make it more difficult for some people to read it and to for format it. New constructs will make your life more difficult. Of course, in order to make our life easier, you need to keep to this approach. For example, you know all about the project, but not everyone who knows what comes next. If your project lives on, we have some new requirements. Let's see, look into a case. There's a case, I don't know if you look into it. You can see there's no formatting, grouped braces, and there's spaces, irregular spaces. It's difficult to really read this code. If you format this code, the reaction to this code will be very sad. You don't know what to do with this. If you format this code, everything will be in their place. And if there's a bug here, will be easy to detect. Another example, certain formation is used here, but not. It's not done. It's not fully done. Else belongs to not to the first operator, but to the second one. If you browse the code, you can simply miss it. If we format it so clear to us, we can see it. When a software product is being developed, it's difficult to evaluate the quality and productivity of the code and to have a certain idea of the code. Certain metrics are used. By metrics, we understand the measure that helps to and allows us to get a certain number and the sum of the software. It was the American engineer Tom DeMarco who said that we cannot control what we cannot measure, supported in metrics. Dynamic metrics shows relatively good result. It allows us to see the regression or improvement in the code. We can detect the problematic models and pay more attention to them. There's a big number of metrics. The number grows up to hundreds or thousands, but in practice, not all of them are used because majority of them are not easily subject to automation. Others are really narrowly specialized. They can be grouped.
For example, there are metrics that are quantitative, where you can calculate something, summarize something. There are metrics that can characterize the difficulty of a software. It's a group of metrics which is especially interesting because complexity is a factor that has an impact on other parameters of your software, code support, testing, reliability, and so on. Object-oriented metrics. Now, let's get familiar with them. First of all, let's get familiar with the quantitative metrics. They are simple. The easiest one is the number of code lines. First, it was created to assess the difficulty of the project, but the languages develop, and now the same functions can be described with different number of lines. Now this matrix is no longer popular because here you can differentiate between physical and logical metrics. There are other quantitative metrics, the number of comments, the percentage of comments to the number of lines. Defect density and regression coefficient are also quantitative metrics. Defect density is determined as the share of defects out of all defects within the framework of iteration, for example, from one release to another. The task of this matrix is to highlight a module with the problems. And this information about the module, separate module, can help you further on improve the quality of the module, develop additional tests, and so on. Regression coefficient determines the number of bugs in the old functional and in the new one. So it's the kind of index that shows you what the team makes efforts to. Do they do anything new, or do they have to fix bugs in the old code? Another complexity matrix is a well-known McCabe matrix or cyclomatic complexity, which is calculated on the basis of the flow management. Mathematically, it is calculated like that. The formula is here. E is the number of edges or plates. You know the number of plates, you know the number of units, and the only thing you need to learn is the number of component connection. The number of edges you need to add to the graph of the management flow to transform it into a powerful graph, which means that you can go from any top to any other top. For the majority of correct programs, in this correct programs, they don't have any frozen entry points and outcoming points, which means that they take it as one. And if you have the entry points, you insert them, then the cyclomatic complexity will be 1. If you add additional components, if, then, she, do, until, while, cases for, the complexity will increase. Here on the slide, you can see such examples of such constructions. Now let's calculate a cyclomatic complexity. Here is an example. We have some method. It consists of fragments. Here is how its management looks like. Here you can see the units, the edges. Here is outcoming point. Here are component comparability, and here is our complexity. Our cyclomatic complexity is 4. They say that higher cyclomatic complexity is not good because it means that in your log you have a lot of cases, cycles, and it all makes it more difficult to understand the code. And if you have a mistake in the code, it will be more difficult to bring it back to order. It will be also more difficult to test such a fragment because the cyclomatic complexity figure says that if you have various linear dependent ways of program implementation. In our case, E is 14. That's why in our code M is 4. In order to cover all the tests, you need to write down many tests, more than 15. Now, let me summarize the information about the metrics. There are a lot of various opinions about metrics, and some say that you have to use them, some say that you need to reject them completely. If you want to use metrics, you need to do it reasonably. The main idea here is that metrics should have an informative recommendation character, because if it becomes some kind of a forced instrument, it will be bad, because programs will be developed specifically for this or that metrics, and it's not good. In terms of dynamics, metrics are good for dynamics, because if you want to take something and calculate the metrics, if it's good or bad for you, it's not clear. So you need a history to see improvements or regression. The problem is that not all the metrics are universal. For your project, for example, this metrics can be good. For other projects, it can be absolutely useless. Now, let's speak about a different thing. Let's speak about the use of stat analysis. There is such a notion of code puzzling, when an initial code has the same function, but it's more difficult to analyze or modify or understand its algorithm. And there is a reverse process. We needed to protect your code from abuses from people and machines. Not everyone needs it, only those who have higher level of protection. If you work with the programs, with documents, with electronic signature, for example, or if you work with games, then you need such a protection to avoid easy patches. So you needed to protect against the program against ill-minded person, and here are two options of obfuscation. So first, you get rid of braces, you rename the objects, you get rid of spaces, and such makes it more difficult to analyze the code by a person. For a machine, nothing changes. Second way is aimed at changing the logics of the program when the functions still remain the same. They add additional cycles, cases, offshoots and derivations to the code. On the left, you can see that everything looks simple. You take the same code, you make more derivations, and the management logic looks completely different. Do you agree that it's more difficult to understand it? But the trick here, in the right case, is that the function still remain the same. Validity checker. If your application works with information, you need to spend a lot of time to process data, to transmit data. And there are well-known formats like JSON, XML, YAML. you're going to work a lot with the data, so you need to automatically check their validity. For this purpose, there are various instruments, such as special instruments for JSON, XML, YAMLint, which can analyze the incoming data and come up with mistakes, syntactic mistakes, braces, spaces, keys. Simple example here is a JSON format. It has a content, and in the content there are two words, title, that are doubled. At the very initial stage, when the file was created, you can check it, and you will see that there is an error. It's like a statistical analysis. The earlier you identify mistakes, the less it costs to eliminate them. Next, in our company, we have a blog about article and documentation check. We also write down a lot of documents about new features, diagnostic rules. Different people write it, interns and well-experienced employees, to make sure that it doesn't happen so that one person is writing an article and other people get deviated. We created a program that we named a publicator. It works in Word. It takes an article from the author, and at the outcome we want to receive an analysis. If analysis is not fine, then this article doesn't go anywhere else, because the author needs to work with it before sending it further on. So we have text here as the source of information, and we can identify errors according to preliminary drawn rules. For example, we can treat such mistakes as links, pictures, that the size is correct, and the pictures look properly. All the articles and all the documents must look properly. If there are some fragments of code, they are also checked. The accuracy of such code fragments is checked. Let me show you an example. It's a check of pictures on alpha channels. We had a bad experience. We created a project, we made an article, and uploaded it to the web page, and we were surprised then when we wanted to see a unicorn at the white backdrop, we got a unicorn at the gray backdrop. We didn't understand how could it happen, why it was gray. We uploaded it to the web page, and they were alpha channels. To avoid such mistakes, now there is an alpha channel picture check. So such things haven't happened after that. Knock on wood. Another example, we check the accuracy of links. Well, we have to give links to sources in the Russian language, and here in the Russian article we have a link to initial document, which shouldn't be like that. That's why we check the links. Next is Compass Expert, inspired with statistic analysis. In 2017, in the row of Compass 3D applications, there appeared another one called Compass Expert. It checks design documentation and identifies problems. If I say about design documentation, I mean drawings, design, and 3D models. And the developers say that they were inspired with our statistic analyzer many years ago when it was called differently. They wanted to develop this ideology. They did so, and they created this kind of a program that checks design documentation according to preliminary drawn rules. It looks like a statistic analyzer, but for designers. Compass Expert checks the documents according to state standards, rules and regulations. These are the rules and regulations you can add to the program because in every country it can be different. And this is how it looks like. Here is a report. You can click on the warning that you are interested in. The Compass Expert catches the necessary drawing and highlights the area with the mistake, and you can correct it. This is how it works. Similar to statistic analyzer. Now I would like to draw some conclusions. We live in the 21st century. It's the era of information technologies. Information technologies penetrate into many areas of life, including healthcare, design, mechanical engineering. It means that IT sphere has to develop more and more applications and programs. Everything needs to be tested and it all needs to be processed. We work with loads of information. For us to be able to make the process good, proper and fast, we use various methods, such as statistic analysis. The 21st century has just started. We have an opportunity to grow, which means that statistic analysis can easily strengthen its position and find new areas of application. Thank you. Thank you for your attention. If you have any questions, please do not hesitate to ask them right now. I will be more than happy to answer. Thank you. For your presentation, I would like to clarify about complexity. What if you have fragments of code that are interconnected? For example, there was a copy and it moved to the function as an argument. Then how do you calculate it? Well, I gave you simple examples of complexity, and I'm not an expert in this area. But I believe that you can calculate everything, because as far as the structure of the program is concerned, instruments know about it. Corresponding instruments can take it into account, and they can identify it. Not really. For example, you register callback in the driver from the user process. It is external for a program. I think that if it's just an opening of the function, then it's a regular linear implementation. You need to check this function, the function that causes external functions, and then you need to test all the functions. Then you will have an overall picture about the testing. Because if you check one method and you forget about the external function, you will have only linear implementation when you call one element. Okay, other questions? Hello, thank you for your presentation. You mentioned that you need to be careful with metrics because metrics might replace the goals and it will be bad. So who has to take the decision that these or that metrics need to be taken into account in the result analysis and these metrics not? How can you say that this dynamics of metrics will be good and this not? Well, there are no rules. I can share my personal opinion. Initially, if the task is to use metrics, you need to calculate as many metrics as possible. These processes are not so difficult. If you calculate it once, it won't help you because you need some kind of history, 1, 2, or 3 months, or even more, when you simply calculate, and then you need to make analysis. Who is going to do it? Perhaps a specialized person to identify the trend of the metrics. So it's like an additional analytics department. Yeah, you need to bring together the parameters of metrics and your goals. Yeah, vaguely, but I got the point. Okay, other questions? Thank you for your presentation. Do you analyze initial code? Yes. It's not the first question like that. We do analyze it every day at build service. Do you see any errors? No, because we start analysis before committing. Such problems might occur, small problems that are identified, but usually the errors are identified when developer is writing a code. So before loading anything, they check their code for possible mistakes. Metrics is good. You need to check everything with metrics. Are there any cases when you cannot use metrics? Do you want to say that you need to calculate something all the time? Yes. Well, metrics, it's a vague notion, and they can show you the quality. I'm not convinced. Well, if you take... Okay. Well, they can calculate complexity. For each method, for example, there should be a certain level of complexity, 10 or 11. If you develop something, you can check your code. If the figure is 15, it means that the complexity is too high, which means that the method should be changed. This matrix is quite popular, for example, and widely used when it can help us analyze various code indicators. I'm speaking about complexity. Yeah. Okay. I have a question about your opinion. Is it for developers or is it for testers to write down more tests? Why do you need to use such metrics? Who needs them more, testers or developers? I think that such metrics can be used during tests and during development. Of course, when a developer is writing a code, he is not going to check what he is doing. It should be some kind of a command from above saying, let's rewrite what you have just written. I think that such metrics can be used at various stages. Hi, my name is Ramil. Thank you for your presentation. I have a question to you. As a vendor, can you tell me if there are any products you compete with? Are there any statistic analyzers that are present at the market that are your competitors? And can we integrate you with CI? And then what metrics will you submit in such case? Or do you have only one-time launch at in initial code, and that's it? First question about competitors. It's hard to compare statistic analyzers because if we compare them, we can choose projects where our analyzer works better and our competitors work worse. And in other cases, we will perform worse. The analyzers have the same goal. Some analyzers work better in some cases, other analyzers work better in other cases. So they focus on these or that mistakes. The advantage of our analyzer is that it's a good form of support, because not all the analyzers have such support. Not everyone is ready to introduce changes. And as for CI, we can be inserted in CI through command lines. You have a report, and then this report goes further on, then can be analyzed. Now, I have one more question. What about your license? Is it open source, enterprise, support? You can use our analyzer free of charge if you make a comment at the beginning of the file. It was done initially for open source projects. We also have this analyzer for the students, but in other cases it's a commercial license. So it's in the form of support. If you use open source program, if you have any questions, and if you write to us, and the question will be good, we'll take it into account immediately. Okay, thank you. Do we have other questions? No. No questions? Thank you all. Thank you. The last question. Can I? Please.